Unit 9.1 Pressure and Gas Laws. Topics in this lesson: pressure, Boyle's Law, Charles' Law, Amundsen's Law, Avogadro's Law. Pressure. Gaseous particles expand to fill their container and collide with the walls. The sum of these forces, divided by the area in which they occur, is the pressure of the gas. 1 atmosphere of pressure is defined as 1.01325 times 10 to the minus 19 newtons per 1 square picometer. Atmospheric pressure. The gas pressure of a sample of air that is equal to the weight force of the column of air above the sample. Consider the picture below. In the column of air, the air particles are accelerated towards the center of the Earth by gravity. They have a weight force. If we consider just the volume of air towards the bottom, it has to counteract the weight force of all the air above it in order to prevent being compressed. If we consider a volume of air higher up in the atmosphere, we can see that it has fewer gas particles above it, and so it has a lower pressure required to counteract that weight force. You've experienced the decrease in atmospheric pressure at high altitudes if you've ever flown in a plane or climbed a mountain. Consider the picture below. At sea level, we have an average sea level pressure of 760 millimeters of mercury, or 1 atmosphere. As we climb a mountain, the amount of air above us decreases, and by the time you reach the top of Mount Everest, you would have only 1/3 of the original amount of air pressure, 250 millimeters of mercury. When your ears pop, your body is attempting to reduce the pressure in your head to match the lower pressure of the air around you. Atmospheric pressure pushing against a container of mercury will push mercury up an evacuated tube. This is called a barometer. The weight of the mercury in the column is equal to the atmospheric pressure. Normal atmospheric pressure at sea level will push 760 millimeters of mercury up the column. A similar barometer could be constructed using water instead of mercury. Unfortunately, because water is much less dense than mercury, the column of water would need to be more than 3 stories tall, or 10.3 meters. This is not exactly suitable for household use. There are various units used to express pressure. One unit is atmospheres, ATM. 1.01325 times 10 to the minus 19 newtons per 1 square picometer, which is roughly equal to the atmospheric pressure at sea level. Another unit is millimeters of mercury. There are 760 millimeters of mercury in 1 atmosphere. There are also 760 torr in 1 atmosphere. There are 101,325 pascals in 1 atmosphere, and there are 1.01325 bar in 1 atmosphere. There are also 14.69 pounds per square inch, or psi, in 1 atmosphere of pressure. Let's practice together. Convert 399 millimeters of mercury to torr, atmospheres, pascals, bar, and psi. Well, first we know that 1 torr is exactly the same size as 1 millimeter of mercury. So 399 millimeters of mercury, doing some dimensional analysis, is 399 torr. We know that 1 atmosphere is 760 millimeters of mercury. So if we have 399 millimeters of mercury, and we do some dimensional analysis, we have 0.525 atmospheres of pressure. 1 atmosphere is equal to 101,325 pascals. So using dimensional analysis with our previous answer of 0.525 atmospheres, we get 53,200 pascal. We also know that 1 atmosphere is equal to 1.01325 bars, Again, using our previous answer of 0.525 atmospheres, we now have 0.532 bars. And finally, 1 atmosphere is 14.69 psi. Using our previous answer of 0.525 atmospheres, we now have 7.71 psi. Boyle's Law. Robert Boyle was born in Ireland in 1627. He is credited with describing the relationship between gas pressure and gas volume. During his studies, Boyle moved to Italy and studied with Galileo. The apparatus used to describe Boyle's law is a J-shaped tube. Air trapped with mercury in a J-shaped tube has a pressure of 1 atmosphere and occupies a volume of V. If 1 atmosphere of mercury, which is 760 millimeters of mercury, is added to the tube, this doubles the pressure of the trapped air. The trapped air is compressed to half the original volume of V over 2. Boyle's law states that at a constant temperature, gas pressure and volume are inversely proportional. A relationship like this can be described as P1 V1 equals P2 V2. Let's practice. A piston with 5 liters of air at a pressure of 1 atmosphere is compressed to a volume of 2.1 liters. What is the pressure of the air in the piston? We use our relationship P1 V1 equals P2 V2. We fill in the values that we know, P1, V1, and V2, and solve for P2. Doing so, we get 2.4 atmospheres. Charles' Law. Jacques Charles was born in France in 1746. He is credited with describing how the temperature and volume of a gas are related. To the delight of onlookers, Charles flew a hydrogen balloon to a height of 500 meters. Charles noticed that with decreasing temperature, the volume of a gas decreased linearly. Different gases exhibited different slopes to their linear relationship, but all gases reached a volume of 0 at a temperature of negative 273 degrees Celsius. We know this as absolute zero. Charles' law can be described by the relationship V1 over T1 equals V2 over T2. Let's practice. A balloon containing 1.5 liters of air at room temperature, 25 degrees Celsius, is plunged into a dewar of liquid nitrogen, negative 196 degrees Celsius. What is the new volume of the gas in the balloon? We can use the relationship V1 over T1 equals V2 over T2, fill in the values that we know, V1, T1, and T2, and solve for the unknown V2. V2 is 0.39 liters. Amundsen's Law. Guillaume Amundsen was born in France in 1663. He is credited with discovering the relationship between gas temperature and gas pressure in a rigid vessel. Here is an Amundsen's Law apparatus. Liquid nitrogen is poured on a bulb which decreases the temperature, and the decrease in pressure is observed on the pressure gauge. Amundsen noticed that in a rigid container, the pressure of a gas rose as the temperature rose. This is due to the increased kinetic energy and frequency of the gas particle collisions with the walls of the vessel. This relationship can be summarized P1 over T1 equals P2 over T2. Let's practice. A glass bottle is sealed at 1 atmosphere of pressure and 25 degrees Celsius. It is then submerged in a pot of boiling water at 100 degrees Celsius. What is the new pressure of the air in the bottle? Use the relationship P1 over T1 equals P2 over T2, fill in the values that we know, P1, T1, and T2, and solve for the unknown, P2. We see that P2 is 1.25 atmospheres. Avogadro's Law. Lorenzo Avogadro was born in Italy in 1776. He experimented with gases and discovered the relationship between the volume and amount, or moles, of gas. His work led to the mole concept and his association with the number 6.022 times 10 to the 23rd, or Avogadro's number. Avogadro noticed that the volume increases with increasing moles of gas molecules. The identity of the gas molecule was not important, he found. His relationship can be summarized as V1 over N1 equals V2 over N2, where N is the number of moles. Let's practice. A 60-liter balloon initially contains 3.5 moles of air. A clown inflates the balloon more by adding 4.8 moles more air. What is the new volume of the balloon? We use the relationship V1 over N1 equals V2 over N2, fill in the values that we know, V1, N1, and N2, and solve for the unknown, V2. V2 is 140 liters.